Okay, good afternoon. So today we want to discuss lecture number 4 in project software management. We want to look at the system and software errors as we use the software for the project. So there are so many ways in which detectable errors can be made. It pays to be very careful during the initial data entry. It's a good practice to have one person key in data and the other assisting by ticking each item off on a copy of the network as it is entered. Basically, this is what we call a clarity check, where you've got two key in data operators. One is a verifier, one is going to do the initial transcription of data. In this way, it avoids to avoid transcription of error as we do the data capture in the system. It can also be useful to print out a complete activity list so that all the data can be checked for errors or even omission. So if you cannot have two data entry operators, you can also do the printout and just carefully go through the material on the paper and cancel out or identify the errors and also register. So we've got what you call error diagnostic in the software project management system. So all good project management software contains a comprehensive error detection routine designed to recognize particular types of mistakes and report them for correction, or for a confirmation that the relevant data are correct as entered, but any apparent anomalies were detected. So basically what you're saying, a very good software management for the project has a built-in error detection method. So errors may originate from transposition or other reading errors, keyboard mistakes, entered in non-valid control data, probably a date which lies outside the main calendar, or some basic flaw in the network diagram logic itself. So for typical errors, which I'm going to discuss basically two typical errors. The first ones, the mistakes or errors the computer can recognize and report back as helpful error messages. And some of these errors the computer can tell as follows: invalid date, because from the onset you set the format of the date that you're going to be using. So if you enter any date apart from what has been set, the computer or the software can detect and report back an error. Duplication of activities, entered in the same activity more than once. The dangles, which I'm going to explain later on below, and also the loops. We'll look at them, just exercise a bit of patience. And also we've got other anomalies where the computer recognizes conflicting data inputs. For example, you say this activity will be done in 0 days. That is not normal. You can't have 0 days of work. So such errors can be detected. We mentioned that we are going to discuss these errors below, like duplication, dangles, and the loops. So a duplicate activity, it is almost certain that a modern system should be able to query or reject duplication. So such are expected to be reported. What have we done? Basically, as we will discuss, already maybe I've discussed in other subjects like project planning and management, we have seen that the only accepted dangles in network diagrams are the head and the tail, the start node and the end node. Any other node within the body, it should not be a dangle. It should not be like the head and the start, otherwise it's called dangle. A dangle basically is when an activity has not been successful or successful. Such activities we call them dangles. That's why you're saying on the head or the start and the tail should be dangles, because the start has no predecessor. The end has no successor. So these two are the only nodes which allow to be that way. Apart from these two, any node in that way is a dump, is an error. And then loops. A loop is a sequence of activities where a path forms a continuous loop. This normally happens when you don't separate the head and the tail from the main network diagram. That's why it is very important from the onset that as you draw the network diagram, you separate the tail and also the head. Otherwise, you're going to be in this situation calling loops. Now, let's talk about mistakes a computer cannot tell, which are very difficult to tell. What are these? Like incorrect activity duration. For example, one particular activity is supposed to take 5 days, and then you type 6 days. The computer can say, wait. What you're thinking is, this activity takes 5 days, but you have typed 6. The computer can't tell what you're thinking, so it will just follow what you're going to give it as an input, as long as it's not actually conflict with things that we've discussed, like the format, the range, and other things. It won't tell. Incorrect name. You write in the name Evans, you actually left out A, or you swap A, okay, with E. The computer cannot tell that you are supposed to write Peter, but what you have written is something else. You have written John. So all these, okay, errors which are a result of human error, which are further transferred to a computer, they cannot be detected because the computer to start with depends on input, where the system is not updated with the detection method regarding that, it won't tell. So now, what is resource scheduling? People are going to look at resource scheduling. Sometimes it is referred to as resource leveling. So resource scheduling should always be considered in any project where project activities requires people or other resources that are within the project manager's own organization. So a typical program will attempt to schedule each activity at its earliest possible time, and will draw down the number of resources for each relevant resource from the total amount of specified as available in the project definition file. So when the activity ends, its resources are released and returned to the available pool for reallocation. So if insufficient resources remains in the pool for activities to be started on its earliest date, the computer will make a decision based on the priority rules set by the plan. So as you use the computer and want to do resource scheduling, you must set priority rules, which we are going to discuss next. The first one, of course, 3 to start with. Let's start with the first one. Influence of float. In project management, when you say float, we refer to 3 times on the project. The times which you can do nothing, but it won't affect the deadline or the submission of the project according to a specified time frame. So when the computer has to delay save activity due to scarce resource, float is often used to decide which of the competing activities claims first priority. So when the computer schedules activity to take place later on its earliest possible date, it has used up some of the total float originally caused by what? The activity and by its following activity. So simply put, activities that requires float, that has free time, they can be put on the bench, so to say, when it comes to resource scheduling, and focus on activities where there is no float and allocate all the needed resources. That's the gist of the matter here. That's the point we're discussing. So the amount of float left in each case is sometimes known as the remaining float, which we'll discuss later on. Perhaps we'll discuss them in other subjects like planning and management. Another rule is time-limited scheduling. So the most important decision the planner must take concerning resource allocation priorities is to decide whether the schedule is to be resource limited or time limited. But in the meantime, we're talking about time limited. So those are the activities where time is very, very important. It's either it is done within a specified time frame or it won't be done at all. So such activities, we need to focus on them, give them the resources they need, because after that, they will be useless. Okay? So if the time limited is chosen, the computer will schedule activities of dates necessary to ensure the project is complete within the time scale specified. So any activity, any other date imposed on the start and the finish of the individual activity within the network could also be given priority. So the computer may even work out resource usage accordingly. What about resource limited? We are just going to discuss the time limited, where time is very, very important. Here it is resources. So under resource limited scheduling, the computer is instructed never to schedule any activity at a date to impose more resources of any particular type to be needed than the total quantity specified as being available for the project. So what's the point? What does this mean? This means that some activities have to be delayed beyond their latest date, keeping them waiting until resources are released from even more critical activities. So there are activities or there are events that needs all the resources for it to be done, or they won't start. If there are no resources for that activity, don't start the project. Right? So it's a situation whereby if you don't have all the ingredients to come up with this product, it won't come out the product you want. Okay? So it's either you have all the ingredients or you don't start cooking. So you have all the ingredients, then you cook. That's what I'm doing. That's the point. So therefore follows that with resource limited scheduling, the project might have to be extended beyond the earliest possible completion date as shown to be possible by the length of that critical path. This term, we will discuss it later on, okay, when it comes to drawing the plans of the project. It is also likely that any target completion date specified for key activities within the network would have to be decided. So we have looked at these three rules. These are very, very important when it comes to resource planning. So when they ask you, can you discuss resource planning and resource scheduling and how the system can ensure that the resources are well utilized? So don't forget to mention the rules that you need to set for the computer to exactly follow what needs to be done so that the project will fail. Right. So people, this is where we can end for now. So the time I would like you to read through this, okay, to go through this video, understand it several times, and try to give me the feedback of what you have learned today. Thanks very much.